Hi, Chris Good here, and this is another video of a mechanism for a neurotransmitter. I'm actually going to start this over. I want my presynaptic neuron to be over here. So that's an axon terminal. Here is the postsynaptic neuron. Let's go ahead and label these. This is the presynaptic neuron, right? This is the postsynaptic, whoops. This is the postsynaptic neuron. And let's imagine that this is some kind of excitatory synapse where we have an excitatory neurotransmitter being released from vesicles here, and they're binding to a receptor postsynaptically over here. Something excitatory like, I don't know, maybe this is a glutamatergic, maybe this is glutamate that's being released into the synapse, and we have glutamate receptor, some kind of glutamate receptor postsynaptically. And it shouldn't be a big surprise to you that when glutamate binds to its receptor, this makes the postsynaptic neuron more likely to fire an action potential. Alright, so that's just a regular old excitatory synapse. Well, similar to the mechanism of adenosine, which we've discussed previously, there's another synapse here. This is the axonic synapse, right? We call it axonic because we have an axon right here synapsing on another axon terminal bouton right there. But, just like other axons, this one is releasing neurotransmitter from the end that it's got stacked up in vesicles waiting to be released. And it's got an inhibitory transmitter in it, right? And the function of this inhibitory transmitter is to bind to its receptor, and guess what? This one is also another one of those G protein coupled receptors. We call it that because it is coupled to a G protein that sits here inside the cell. It's got a couple of different parts to it. So let's label that. This is G protein coupled. But it's a receptor for a specific neurotransmitter that's in the vesicles up here. And this one is called endorphin. Alright, so this is, we don't call it an endorphin receptor, we call it an opioid receptor. We call it that because all of the opioids bind to it really, really well. So you may, for some reason, have an opioid here in your bloodstream. Now it could be because you've received morphine, which is a potent pain reliever, and that morphine floats around and gets everywhere in your brain. It doesn't do anything until it finds something to stick to. So this molecule of morphine may float around like that. Now, what I didn't tell you about the opioid receptor is that when the regular neurotransmitter, endorphin, binds to the receptor, this little piece of G protein comes off and it floats around inside the cell and it does stuff. And without going into too much detail, let me just say that ultimately it slows down the release of excitatory neurotransmitter from the presynaptic to the postsynaptic neuron. So endorphin normally decreases excitation. It inhibits the release of excitatory neurotransmitter. And what opioids do is they bind to the opioid receptor and activate it just as if endorphin were there. So we can say that drugs like morphine and heroin and OxyContin and codeine, right, are opioids, and they are opioid receptor agonists. An agonist is something that activates the receptor either directly, like this one does, or indirectly in some way. So when the opioid is bound to the receptor, this piece of G protein comes off and it limits the release of excitatory neurotransmitter. And that's how we get the depressant effects of this drug, decreases in things like anxiety, decreases in things like respiration rate, decreases in perception of pain, and things like that. It's all because this drug molecule resembles endorphin and it acts on opioid receptor as though endorphin were there as an opioid receptor agonist. And that's how heroin and morphine and all the rest work.